All right, welcome to lesson 9.7. We are going to graph and analyze relationships using tables first. So we've been working on tables and finding rules. And then we're going to take some information we learned at the beginning of chapter 9, where we can take two numbers in a table and make ordered pairs, right? So the essential question, how can you write and graph ordered pairs on a coordinate grid using two number patterns? So we've been working with number patterns for the last two lessons, putting them in tables, finding a rule. Now we're going to use those numbers to make ordered pairs and put them on a coordinate grid. We're kind of taking all of this stuff in chapter 9 that we've been working on, and we're putting it all together in this lesson, okay? This is the last lesson of chapter 9, so it's kind of bringing it all together. So let's check it out. All right, first thing is unlock the problem. So let's break it down. Let's use what we already know and put them all together. So Sasha is making hot cocoa for a party. For each mug, she uses 3 tablespoons of cocoa mix and 6 fluid ounces of hot water. If Sasha uses an entire 18 tablespoon container of cocoa mix, how much water will she use? Okay, so we got our numbers up here for our beginning. So one mug will have 3 tablespoons of cocoa mix, and one mug will have 6 fluid ounces of hot water. So we got those numbers for each mug, right? For each mug, okay? Then we are going to solve this question, and I'm going to show you, we know how to solve this question using the rule already, right? And we could use the rule, that's fine. But we could also actually use this graph. So that's what I'm going to show you today, okay? If Sasha uses an entire 18 tablespoon container of cocoa mix, so not just 3, she wants to use all 18, how much water is that going to take? Okay, so let's start off with our table. I already started it off. For one mug, it's 3 cocoa mix tablespoons and 6 fluid ounces of water, right? So that's what I got from the word problem, 3 and 6, 3 and 6. Okay, so let's imagine that she's making 2 mugs of hot cocoa. So 2 mugs of hot cocoa means 3 more than that, which means 6. Okay, and 6 more fluid ounces, which would be 12. All right. What if she was making 3 mugs? So we add 3 more, that would be 9, and we add 6 more, that would be 18. For 4 mugs, we would need 3 more for 12, and remember, this is going up by 6. 6 more for 24. All right? Okay, and then this one is for my question. So 18 tablespoons of cocoa mix is going to be how much water? So I got my 18 ready in the cocoa mix line. I've got to find out this number, right? I've got to find out how much water. So I could just solve it right now. I could find the rule and solve it, but I'm going to show you another way, okay? The other way is by graphing. All right, so we are going to make ordered pairs from this table. We learned that at the beginning of chapter 9 in like lesson 3 or something. And this means like we need to find partner numbers, right? Numbers that are related that we can make ordered pairs into. And since our question is about cocoa mix and water, I'm going to use cocoa mix and water numbers. This is going to be my ordered pair. So 3, 6. Okay, this is going to be my ordered pair, 6, 12, and then this one, 9, 18. And remember, we put ordered pairs in parentheses. Okay, and then our last ordered pair is going to be 12, 24. So 12, 24. All right, now that I have ordered pairs, I can graph these. And there's going to be something really interesting about this graph, okay? A lot of our graphing before, the numbers went up, they went down, the points were everywhere, right? This one's going to do something pretty interesting. So let's see if you can see it while I'm graphing these. So my first ordered pair is 3, 6. So that means go starting at 0, go over 3 and up to 6. If you notice, I counted by 3s in my water and I counted by 3s on my cocoa mix. That's my scale, right? So over 3 and up to 6 would be here. All right, next one, I'm going to put a check so I know I'm done. 6, 12, I'm going to go over 6 and then up to 12. Okay. That one might be a little bit high, but 12. Check. Next one, 9, 18, over to 9, up to 18, about there. All right, and check. And my next one, 12, 24, over to 12, up to 24. Now my paper doesn't have lines for me, but if we were to do this on grid paper where it's got the lines going across and up and down, that would be so helpful. But what do you see about these points? Okay, they're about as accurate as I can get them. What do you see going on with these points? They're going in a what? Right? They're rising up in a straight line. Okay, that's because we have that pattern over here. Since we have that rule that it's multiplying by something to get the bottom number, and it's the same rule throughout the whole table, that makes our dots, our ordered pairs, go in a straight line. Okay, and what's really cool is when I make that straight line, okay, what if I make that line longer and I just keep following that line? Okay, this is going to help me answer the question. All right, so now instead of finding the rule and using the rule to do the table, I could just look over here. So if I go over to 18, because remember it's 18 tablespoons, how much water is she going to use? If I go over to 18 and I go up to my line, it's about here. Yeah, about there. Okay. And then how do I find out how much water for that? So 18 line is about, or the 18 dot is here on the line, because remember it has to be on the line for that rule. If I look over here, how much water is that? It's about 36 fluid ounces. So I can actually get my answer from the graph to solve now if I do this, okay? Let's check by filling in this number and see, is it 36? So first, to do that, we need to know the rule. How do I get from 3 to 6? How do I get from 6 to 12? How do I get from 9 to 18? And a lot of you are telling me it's multiply by 2, right? So times 2 is 6, times 2 is 12. Yes, so it works for all of them. And then we do 18 times 2, and what is that? Is it 36 like I got on my graph? Yes, it is, right? 18 times 2 is 36. So there's my answer. It takes 36 fluid ounces of hot water for Sasha to use the whole can or the whole container of cocoa mix. Okay, so how much water will she use? She will use 36 fluid ounces of water. There's my answer. Yes? All right, there's unlock the problem. Let's try another one or two. And we're pretty much doing the same thing. So let's use the word problem to start a table. I already got it going for you. And this word problem is much smaller. It says each $2 bag of copper wire contains 6 meters of wire. So in one bag, we got $2. It costs $2 for a bag. And then 6 meters of wire. What if I had 2 bags? Okay, 2 bags would cost me double, right, than the $2, so it would be $4. And then 2 bags would have 6 more, so 12, right? What if I had 3 bags? Well, $2 more for another bag, so it'd be 6. And 6 more meters of wire, so it'd be 18. 4 bags of wire would cost me $2 more, so it would be 8, and it would be 6 more meters of wire, so 24. All right, so there's my table. I'm going to leave this one blank for later when I answer my question, which is at the bottom. But let's just solve from here. So far, we know that these are following a rule, but these numbers are related, right? So I'm going to make ordered pairs next. So ordered pairs for here is going to be 2 and 6. 4 and 12, 6 and 18, 8 and 24. So 2, 6, 4, 12, 6, 18, 8 and 24. There we go. There's my ordered pairs. Okay. I can graph them. There's my graph going over there. And if they make a straight line, then that means that I've got a rule, right? If I have a straight line on these points, then there is a rule being followed, and I can use the rule to solve the question, or I can use the graph to solve the question. It's up to me. All right, 2, 6 means I'm going to go over 2 up to 6. There it is. Okay, 4, 12 over 4 up to 12, about right there. 6, 18 over 6 up 18, about there. And then 8, 24 over 8 up 24, about there. Did it make a straight line? Yeah, pretty close. If I had graph paper, it would be much, much straighter, but I can still use this. It's fine. All right, I'm going to extend that line. So that means if I had 10, I can go up here and I see how much the wire that would be, right? 10 would be about 30, okay? If I had 12, I go up the line, and how much would that be? It's about 36. It's a little off, but it's because I don't have graph paper. All right, so extended the line. And now I should be able to answer this question. I can use a rule. I can make a rule to answer this question. I might make that in a second to double check my work at least. But if I just use the graph, I can, okay? And it says, how can I use the graph to figure out how many meters of wire can be purchased for $12? So if it's $12, that means I'm going to start down here where it says dollars and cost. I'm going to go over to 12, and I'm going to go straight up to my graph and make a dot. Okay. And then from there, I'm going to look over to see how much it would cost. And it's about 36. It's kind of between the 33 and 36, but it's because I don't have lines on my graph, you know. But I can double check my work. I can double check it by writing the rule and solving it in the table too. So let's see, is it 36? I'm gonna guess it's 36 using my graph, okay? And then let's see. So how can I check? I can find this rule. So how do I get from 2 to 6? How do I get from 4 to 12? How do I get from 6 to 18? And that rule would be multiply by 3, right? We're going to multiply the top number by 3 to get the bottom number. So times 3. Okay, and our question said for $12, so we're going to put 12 here in the cost. We times it by 3, and what is 12 times 3? It is 36, so it's going to cost 36. So my table was right. I'm $36. My graph was right. So it's $36 to, or not, I'm sorry, not dollars. 36 meters of wire is what he would get for $12, okay? And I used my graph by going over to the 12, going straight up, and then looking across. All right? All right, let's do one more. This one says, on a map, every 2 inches represents 10 miles. Okay, for this table, I don't really have like a header up here. It's just on a map, okay? And you know how on a map, it's kind of like brought down to scale, so everything's much closer on a map than in real life, right? And for this one, their scale is 2 inches. So if things are 2 inches apart, that's actually 10 miles on the map, all right? And so 2 inches represents 10 miles, so we have 2 inches, 10 miles, okay? Let's go up by 2s. What if it was 4 inches? How many miles is represented in 4 inches? Well, if I doubled this, then that means I'm going to double this, so 20, right? 6 inches would be, I'm going to add 10 more, would be 30, right? Okay, if these are going up by 2s, I'm adding 2 more inches, then that means I'm going to add 10 more miles, add 10 more miles, right? I'm going to do one more, 8, and then 10 more would be 40. All right, I think, there we go. And then I'm going to use this to check my work, okay? Because I do have a question down here. All right, let's use the numbers I started with to make some ordered pairs. So these are the numbers that are related to each other. So I'm going to have 2, 10, 4 and 20, 6 and 30, 8 and 40. and these are my ordered pairs. All right. If they make a straight line, then that means that there is a rule. That means that I can use a multiplication rule or a division rule to help me find one of the numbers if I have the other one given to me. Okay. So let's see. So over here I set up my table. The y-axis is miles, and it's going up by tens from 0 up to 70. And then my bottom, my x-axis is inches. So for 2 inches, I said it was 10 miles. So my ordered pair is 2, 10. So I'm going to go over to 2, up to 10. Oh, use this one. Over to 2, up to 10. Over to 4, up to 20. 4 and up to 20. Over to 6, up to 30. Over, up. Ooh. 8 to 40. So over to 8, up to 40. Okay, is it making a straight line? Yes, it is. That's because they are going up at the same rate. So they are definitely following a rule. Okay, I'm gonna extend my line. All right, so now I can use this line to answer questions, right? Now I can use this line to answer this question down here. How many miles would 14 inches represent? Okay, yeah, so 14 inches represent. So if I have the 14, which is right here, okay, I can follow this up to my line and then look over to the miles to see my answer, to find the miles. Okay, so let's try it. So if I have 14 inches, that's right here on my graph, and then I go up to my line. Ooh, I almost don't have a long enough line. 14, right there, about there, okay, and then I look over to my miles axis, and I got 70, so I'm thinking it might be like 70. Okay, so that's what I think is my answer. I'm going to say 70 miles down here, but I can check. Okay, I can check by finding the rule, because remember I said it's going in a straight line, so there's a rule, and then using the rule to fill in my table. Okay, so if I want to find for 14 inches, that means up here I want 14 inches on the inches line, and I need to use a rule to get to this number. All right, and if this is 70, then I was right, and we're good. Okay, so let's see. What's the rule, though? What do I multiply it by to find out? So we got to look. 2 times what makes 10? 4 times what makes 20? 6 times what makes 30? Anybody know? It's 5. So the rule is multiply by 5, right? Or multiply the inches by 5 to find the miles. So we're going to times 14 by 5. 14 times 5. I'm going to do some side work. 14 times 5 is 20. 5 times 4 is 20. 5 times 1 is 5 plus 2 is 70. Right? 5, 6, 7. 70. So I got it right. So I can use my graph to solve questions too, or to answer questions too. So lesson 6, we use the table to answer the questions. We use the rule and the table to answer the questions. And then this time, lesson 7, we're using ordered pairs and graphing a long line to answer the question. And they both work. All right, that is it for lesson 8. And that is actually it for lesson 9. So go ahead and start preparing for that's it for chapter 9. So start preparing for the chapter 9 test, guys. It is going to be coming up in the next few days. Have a great day. Bye.